Hello, everyone, and welcome to another edition of Ask the Expert. We're honored today to have Peter Gray with us. He is the president of Air Solutions. Peter, how are you doing today?
I'm doing great. Thank you very much.
Good.
And you?
We're doing great, man. I can't complain. We're really excited to have you on and really sincerely appreciate you taking the time to be with us today. We'll kind of dive right into the questions. If you can, let me know what is the Save on Energy program?
The Save on Energy program is based in Ontario, Canada, and the province of Ontario are currently focusing on a huge drive to conserve energy.
Okay.
And their other option is to build another power station, which, for obvious reasons, they're frowning upon, and they're now in a process of trying to encourage electrical users to reduce the amount of energy that they're using. And with compressed air being such a massive consumer of hydro and electrical energy, we are a prime candidate for helping the province of Ontario reduce their energy usage and consumption.
That's great. Is that something that you see expanding to other places? Is it specific to Ontario? How do you kind of see that working? That's a neat program.
It is a neat program, and the great news is that there have been some deadlines where they have threatened to close the program, and we're into the third extension of that now, and that lasts currently until 2020. So we have at least another 4 to 5 years of the program running for us in Ontario specifically, but there's definitely other opportunities across Canada that I'm aware of, in Quebec at one end of the country, and also in British Columbia at the other end of the country. So we do know that other provinces, which would be equivalent to states in the US, they are trying to partner with companies like lighting companies and compressed air companies to identify areas within a factory or commercial or residential facilities where we can reduce energy usage.
Oh, that's good. So it sounds like it's obviously a relatively new program. What specifically do we know about it? And you kind of touched on it a little bit, but can you kind of expand on maybe some more nuances to it?
Sure. So there are pretty much, from a compressed air standpoint, 4 avenues that we can investigate. One is almost a one-page or an online one-page application, and it focuses on very, very low-hanging, easy-to-pick fruits. And we can talk about that later if time permits. And it gets as detailed as looking at absolutely everything within a facility, which would be known as the detailed engineering study, where they look at compressed air loads, cooling, chilling, distribution of pipe work, the whole 9 yards, where you really do drill down into every nuance of a facility and everything that's using hydro and ways to make that more effective and obviously reduce the amount of hydro you're using in any given facility.
Well, that's great. Are there any kind of like specific rules of thumb, or any specific objectives or in-game targets that we set or aim for?
There most definitely are, yes. Now there's some pretty strict guidelines. But as long as you adhere to the guidelines, the actual application process is very, very simplistic. We have a team of experts here that specifically focus on the Save on Energy applications. And what we know is we've done now over 150 of these applications, and every single one of them has resulted in our customer getting a rebate from the Ontario Power Authority. The check that they get ultimately doesn't come from the OPA or the Ontario Power Authority. It's filtered out to end users via local hydro providers. So your local hydro provider would take care of receiving the application and ultimately paying out on any rebate that was forthcoming.
That's great. And I'm assuming that like these come from inefficiencies within the system. What would you say actually defines inefficiencies?
That's a great question. There are a number of them. Typically, the ones that we highlight first are the low-cost, no-cost solutions.
That's great.
Which might be something like a compressed air leak. for anybody that either does or doesn't know the cost of compressed air, it potentially is the fourth most expensive utility in any manufacturing plant, or at least in our experience.
Absolutely.
So from a quarter-inch orifice, certainly up here in Canada, we calculate that that's probably losing 104 cubic feet per minute at 100 psi. If we're paying somewhere close to 10 or 11 cents per kilowatt hour, we're actually talking about thousands of dollars a year just to feed that one leak.
Wow.
If you start to expand that through a large manufacturing facility, potentially there's thousands of dollars being leaked out of the pipework system and other misuses.
So that's great elaboration on inefficiencies, and it's mind-blowing to me, and I don't think a lot of companies realize how much waste is being let go and let out of their system, and you say it like that, I think it gets a lot of people's attention for sure, because it's real and it's a real cost. What are you mentioned some low cost energy saving opportunities? What are some of those?
We see all sorts of poor practices, for want of a better description. In some facilities that we've had experience in, they would have maybe a multi-bank of air compressors, maybe 3 or 4 compressors in a line, and on Monday morning they would turn every single one of them on and then either leave them until Friday night and then turn them off, or sometimes forget to turn them off and then run them over the weekend. We have a package that's able to data log what the compressors do between Monday, Friday, or even over the weekend.
Wow.
And we've often found that they were running 3 or 4 machines when they actually only needed to run one, or even a fraction of one to meet the entire demand. But they just always did it that way, so they never they changed their habits.
Yeah.
And we come from an educational approach standpoint where we're trying to educate the end user on the cost of compressing air and what it might be if they do that more effectively and more efficiently.
That's really good. And, again, it just goes back to, unfortunately, I think so the natural question would be, why would you have that many compressors if you don't need them? And I think, unfortunately, there's a lot of people that sold somebody too much compression. And like you said, they just kind of continue to run it. Nobody ever thinks to do an audit and check.
Yeah. Now, the other thing, if you're running, let's assume there are 4 in a station, you're doing maintenance on 4 machines as well on a continual basis.
Point. Yeah.
Typically unnecessarily.
Yeah.
And it often tends to be that they needed 4 compressors back in the good old days where everything was pneumatically driven. Well, efficiencies have increased in all sorts of point-of-use applications, and some of those processes may have been eliminated completely from production, but no one ever thought to go back and look at the generation plant to see if it was still necessary to run perhaps 4 compressors or a large amount of horsepower.
No, that's a good point. And so we kind of elaborate on some of this, or talked about some of this, but do y'all, can you kind of go into some more just specific misuses?
Sure. So we often see too many machines, improper control, air receiver tanks that either don't exist at all for storage of compressed air or are sized incorrectly and not engineered properly. We see very poor distribution pipework feeding the points of use. The common practice would be to create a loop around the system so that everybody gets equal pressure. Sometimes we go into a factory and the pipework goes through the middle of the plant, and at the end it just dead ends. So the guy at the front gets lots of pressure, but the guy at the far end of the factory gets none at all or suffered from low pressure. So we try and correct those, or at least make suggestions to correct those and bring them in line with best practices. We also see valves being left open to drain oil and water condensate from the system. We should be putting some kind of check and balance there as well, perhaps an automatic condensate drain. And then we see good automatic condensate drains and we see bad ones, and we try and correct that practice also.
It's a good point. And we kind of touched this a little bit earlier, but, designing these systems is probably more complicated than what people give it credit for. And then also coming back and maybe, like you said, they've changed their operations completely in a 5-year period. So that makes a lot of sense. And so so kind of touch on that. As you looked at a lot of systems, what do you see any kind of common mistakes that you see that may increase operational cost?
We absolutely do, yes. So we're huge proponents of you can't improve what you don't measure. So our typical advice is to first measure and lift the lid on the compressed air system to actually see what's underneath the lid, and then we can identify inefficiencies. We can suggest best practices, and you don't always need to buy a new air compressor. We sometimes can control the system differently, increase storage as mentioned earlier. So it's not necessarily that you're going to buy a new air compressor.
Which is a good point, because leading to the next question, how much does it actually cost to run an air compressor?
Well, it would depend on the horsepower, but in Canada, we're talking about for 100 horsepower, as an example, it could be upward of 50 to 60,000 Canadian dollars.
Okay, that's a good rule of thumb to have, and we'll definitely put that out there, because that really is a good rule of thumb. We
now, shift patterns and things of that nature obviously affect that. So everything's relative to how big the horsepower is, what are you paying for hydro, and how long do you run the compressor for during production times.
Well, we kind of touched this a little bit earlier. Can you just kind of elaborate a little bit more? I think, we talked about leaks and cost, but I kind of want to get back to that point a little bit more. How much do leaks cost? I mean, that's just something that you guys could catch and fix. How much does that cost a company for somebody that may just be out there watching it?
We recently did a leak detection survey. So we have an ultrasonic gun, which is a device that's able to sniff out a leak or detect a leak from 50 feet away from where the operator is holding the gun.
Oh, that's awesome.
Yeah, the operator wears headphones during the leak detection process, so it can be done during normal working hours and during production time. And we've recently implemented this process at an automotive plant local to us, and they found $37,000 of leak potential.
Wow, that's great.
So when we find a leak, we obviously tag it with a numeric number system.
Right.
The gun captures the decibel rating of the leak, and then the program that comes with the gun typically quantifies the sound versus the CFM loss of compressed air. And we're then able to completely show a metric of what you're losing today, and if you fix it, what you would ultimately be saving in the future.
Man, that's really neat. That's really cool stuff. And I think, again, it's like I said earlier, I mean, nobody realizes how much pressurized air costs until you're in the business and you see it. And you're right. It's the fourth utility. And, when these plants, when their air shuts down, when things shut down, you don't just slow down your operation. You send people home because you can't move your parts and you can't do things that you need to do to run your business. So, I mean, Peter, that was a great point, on several of the different things with leaks and different issues and obviously size in your system. I'm sure from a cost saving standpoint, or if somebody's just watching this going, is there one just standard package or one kind of standard solution that could fix these problems? Do you see that?
We certainly do, and potentially there might be, but it's no secret that no two facilities will be the same.
Right.
So we don't believe that one size fits all. We often see our competitors going into facilities and recommending a catalog approach where they're saying variable speed drive compressors will solve all of their issues. And we are great proponents that you should be doing a study first to actually verify and take out any guesswork to see if the variable speed drive machine actually is the right fit for the solution.
Well, that's a great point. That's because you're right. I mean, you're going to have different sizes, different applications, different things. I think that's great advice to actually have it looked at before you just buy a compressor. So that's great.
Right.
Well, that's it for Ask the Expert, Peter. We just can't thank you enough. I think a lot of really, really good information. We encourage you guys to look at the website, airandnose.com. We are trying to promote this industry. We're trying to educate people on what a great industry it is that we have, and hopefully we can get the word out. So, Peter, thank you very much for being a part of this, and maybe we can get you on again in the future.
Yeah, I'd like that. Thank you very much for the opportunity, and good luck.
Thanks, Peter.
Thanks. Cheers. Bye-bye.
Hey, listen, I really do appreciate it, man. That was a lot of fun.
That was awesome.
Yeah, thank you.
Thank you.
And
Cheers.
y'all, hey, take a look at the website, spread the word. There's advertising opportunities, but in all honesty, I mean, Peter, that was a great point, on several of the different things with leaks and different issues and obviously size in your system. I'm sure from a cost saving, either from a cost saving standpoint or if somebody's just watching this going, is there one just standard package or one kind of standard solution that could fix these problems? Do you see that?
We certainly do, and potentially there might be, but it's no secret that no two facilities will be the same.
Right.
So we don't believe that one size fits all. We often see our competitors going into facilities and recommending a catalog approach where they're saying variable speed drive compressors will solve all of their issues. And we are great proponents that you should be doing a study first to actually verify and take out any guesswork to see if the variable speed drive machine actually is the right fit for the solution.
Well, that's a great point. That's a great, because you're right. I mean, you're going to have different sizes, different applications, different things. I think that's great advice to actually have it looked at before you just buy a compressor. So that's great.
Right.
Well, that's it for Ask the Expert, Peter. We just can't thank you enough. I think a lot of really, really good information. We encourage you guys to look at the website, airendknows.com. We are trying to promote this industry. We're trying to educate people on what a great industry it is that we have, and hopefully we can get the word out. So, Peter, thank you very much for being a part of this, and maybe we can get you on again in the future.
Yeah, I'd like that. Thank you very much for the opportunity, and good luck.
Thanks, Peter.